Hello everybody, welcome to SkyGuru. This is the class 3 of block 1 mathematics for CFD. This class is about scalar field visualization using Python. This lecture is presented by Dr. Aishwarya Kumar. I'm a PhD in mechanical engineering from City St. George's, University of London, and I work for SkyGuru. So as we already discussed, what are scalars? So scalars are rank 0 tensor and they have only magnitude. They have no direction. Let us try to visualize the scalar field. For example, the temperature field in one dimension. So what we will do is we will open the illustrations now. Here is the temperature field shown in one dimension. At x is equal to 0, the temperature is equal to 300K, and at x is equal to 1, the temperature is also 300K. So temperature is not increasing between two positions. Now what we can do is we can add a heat source in the middle. Let us say at x equal to 0.5, and it will make difference in the temperature field now. So let us try to illustrate the temperature field. So here is like, let us plot t versus x graph. T here, x equal to 1, x equal to 0, and t equal to 300K, and here t equal to 350K. And due to this heat source in the middle, the temperature profile becomes something like this. We obtain a bell curve. So what we will do now is we will try to model the same phenomena using Python code, but I will also show you the mathematical model by which we can do it. So the localized heat source can be represented using the Gaussian function, where t is a function of x equal to 300 plus 50. 50 is a delta t times exponential of negative of x minus 5 square by 0.02, where 300 is the base temperature, 50 is the strength of the heat source, x is equal to 0.05 is location of the maximum temperature, or the place where we added the heat source, and the exponential terms is used to model how temperature decreases as we move away from the center. So what I will do now is write a Python code to model this equation and plot it. So let's start creating a Python file. New file, and I'll call it 1D temperature profile, and I will start with importing libraries. This is to discretize the space between 0 and 1. If you want it, I can show you what it does. Then I'll proceed further. What is the problem? Let me see. I think I have to click again. So see what it is doing, it is dividing the space between 0 and 1 by 100. So it is creating 100 divisions between 0 and 1. So now what I'll do, I'll proceed with program. So I'll try to write the equation for the temperature profile. 300 plus 50 times np dot exponential minus negative of x minus 0.5, and then I'll square it and divide it by 0.02. Then I'll try to plot it between x and t. Label for x. Do the labeling for y now. And then for title, and I'll try to write a code to show the plot. Let's hope it runs. Save, and then so now we can see I have successfully managed to create the one-dimensional temperature distribution using the mathematical formula on Python programming language, and you can see, as expected, we obtained the bell curve for the temperature, reaching peak at x is equal to 0.5 as expected. So what I'll do now is I will let you see the program for some times so that you can copy it and do it on your computers, and then we will start with two-dimensional temperature distribution, or we can say two-dimensional scalar field visualization. So let us try to visualize the temperature field in two dimension. So let us open the illustrations first. Here we can see that I have drawn a temperature field in two dimension. Here the temperature is constant across, and now what we do is we have added a heat source in the middle, and now it will influence the temperature field. I will show you the model by which we can do it. So let us open the PowerPoint slides. So when we want to do the same in two dimension, we will be using a similar equation. which is Gaussian field distribution. Here we can say it is Gaussian temperature distribution. The equation is almost identical to the previous one shown. The only difference is that we have y minus 0.5 square included in the exponential term, which is here, and this is actually the center of the hotspot, or we can see the center of the heat source. Now 300 is again the base temperature of the domain, 50K is the strength of the hot region, and 0.5 comma 0.5, or we can say x equal to 0.5 and y equal to 0.5 is equal to the position where we have put the heat source, or the center of the hotspot. And this exponential term represents how the temperature decreases as we move away from the center. So now what we will do is we will try to model the equation shown in previous slides using Python programming language. So let us open the VS Code first. Start with a new file, Python file save as, let us call it 2D temperature profile, and then let's start with importing libraries. Let us create a mesh. Let's try to write the equation for the temperature field. I think we have got an extra bracket. I have to see where I might be wrong here. So just give me a moment. I think I'm wrong here, so I will correct it. So now what I will do is I will try to finish the remaining of the program. This is a command to plot the temperature field. Let's give it a title. Let us try to see if it runs or not. Let's hope for the best. Let's try to run this program. I think I'll have to use the run again. It's running but not showing. Let me see what is wrong. It's definitely running. It's not showing. I'll check it. I think I've got some issues with my VS Code. I have to click on this run button 3 times, then it starts showing. So let us do it again. And now you can see that we have successfully generated the 2-dimensional temperature profile, or we can say the 2-dimensional scalar field or temperature field, and we can see that the maximum temperature is at the center and it decreases as we move away from the center. So what I will do now is show you the code for 10 seconds so that you can write it on your computer and run it and plot temperature field like I did. So I would like to thank you again for watching the tutorial and spending your time on this video. If you want any technical assistance in mechanical engineering, design and simulation, you feel free to contact us using our email address info@skyguru.in, or you can use our alternative email address indiaskyguru@gmail.com. And you can also use our WhatsApp. It's +91 983 983 9753. And if you found this lecture useful, please considering liking it and subscribing to our channel to support us. Thank you very much. All the best.